Hi everyone. In this video, we are going to see what is meant by 4-bar or 4-bar chain and inversion of 4-bar chain. Okay, first of all, here we see the 4-bar chain or a quadratic cycle chain mechanism. A 4-bar chain is the most fundamental and the simplest kinematic chain. It consists of 4 links and 4 turning pairs. The figure shows the 4-bar chain. It consists of 4 bar and 1 rotating element. Since the 4-bar chain looks like a cycle frame, it is also known as a quadratic cycle chain. In a 4-bar links of a 4-bar chain frame, here we seeing the frame. The fixed link is known as called as a frame. Here we see AB is a fixed link, so AB is called as a frame. Next one is crank or ribbon. A link that makes a complete revolution is called as a crank. The link AD is completely rotating in 360 degree. It is called as a crank or ribbon. The next one is coupler or connecting rod. The link opposite to the fixed link is known as a coupler or connecting rod. In other words, the coupler is a link which does not connected to the frame is called as a connecting rod. Here we see the diagram. D and C is called as a connecting rod. Next one is lever, or it is called as otherwise called as a rocker or follower. The link which makes the oscillation partially rotated. It is called as a partially rotator. It is called as a lever or rocker or follower. Here we see the diagram. BC is called as a lever or a rocker or a follower. These are the 4-bar chain. It transmits the power from one links to other link. Next we are going to see the inversion of 4-bar mechanism. In that inversion of 4-bar mechanism, we are going to see what are the types and for some few example for inversion of 4-bar chain. Here is the 3 examples: beam engine, coupled rod of a locomotive, or a watt indicator mechanism. Here in the bracket it is noted in a crank and a lever mechanism. Beam engine is working under the principle of crank and lever mechanism. Coupling rod of a locomotive is working under the double crank mechanism. Watt's indicator mechanism is working under the principle of double lever mechanism. Okay, first of all we are going to see what is beam engine, or it is otherwise called as a crank lever mechanism. Beam engine is an example of crank rocker mechanism where one link is oscillated while the other rotates about the fixed link. The figure shows the connecting rod, lever, piston rod, vertical reciprocating motion, and also cylinder, frame and a stand. When the crank link 1 rotates, the lever link 3 oscillates. The oscillator motion of a lever is converted into a reciprocating motion of a plugger in a cylinder as shown in a figure. Thus, this mechanism is used to convert the rotary motion into a rotatory motion. Okay. Next we are going to see coupled rod of a locomotive or a double crank mechanism. Coupled wheel of a locomotive is an example of double crank mechanism where both crank rotates about the point in the fixed link. It consists of 4 links and opposite links are equal in length, are shown in a figure here. Since link 1 and 3 works as a 2 crank, the mechanism is also known as the rotary converter. This mechanism is used to transmit rotatory motion from one wheel to the other wheel. It is called as a couple of locomotive wheel, or it is called as a double crank mechanism. The next one is Watts indicator mechanism. This mechanism was invented by James Watt, for which steam engine to guide the piston rod along a straight line. It is known as a simplex indicator. As shown in a figure, the Watt indicator mechanism consists of 4 links. Link 3 is fixed, link 2 is ABCD, link 3 is CDP, and link 1 is BDE. The link ABC and CDP act as lever, and due to this, the mechanism is also known as a double lever, double rocker mechanism. The point E is connected to piston of indicator cylinder and the displacement of a point E. And the link BDE is directly proportional to the steam or gas pressure is the indicator diagram. In the diagram, the continuous line describes the initial position of a mechanism, whereas the dotted lines shows the position of a mechanism when steams or a gas pressure acting on the indicator piston. The point P traces the variation of a pressure in the cylinder. It may be noted that the point P traces approximately the straight line motion corresponding to the motion of E. For this reason, this mechanism is also known as straight line generator mechanism. It may be any small displacement of a mechanism, the tracing point E at the end of a crank link CE traces. Next one is inversion of slider crank chain. In that inversion of a slider crank chain, we are going to see slider crank chain when one of the turning pair of a 4-bar chain is replaced by sliding pair. This is known as a single slider crank chain. From the single slider crank chain, 4 different inversions can be obtained by fixing its 4 link, one at a time in turn. These are all the examples of a single slider crank chain: reciprocating engine, reciprocating compressor, pendulum pump or a bulb engine, oscillating cylinder engine, rotary internal combustion engine, crank and slotted lever quick return motion engine, Whitworth quick return motion hand pump. These are all the examples of slider crank chain. Okay. In that reciprocating engine and a reciprocating compressor, the mechanism may be seen. The figure shows what is the link 1, link 2, link 3 and link 4. In a reciprocating engine, link 1 is fixed link, link 2 is crank, link 3 is connecting rod, link 4 is slider or piston. From a figure, it is a reciprocating engine, link 4 is a driver. In a reciprocating compressor, link 1 is fixed, link 2 is crank, link 3 is connecting rod, link 4 is slider or piston. From a figure, it is the reciprocating compressor, link 2 is the driver. Now we are seeing the pendulum pump or a bull engine. In this mechanism, the inversion is obtained by fixing the cylinder or link 4 as shown in a figure. In this case, when the crank rotates, crank means is the link 2 is a crank, the connecting rod link 3 oscillates about a pin pivoted to the fixed link 4 at A, and the piston attached to the piston rod reciprocating. In this mechanism is used to supply a feed water to a boiler. Next one is oscillating cylinder engine. The arrangement of oscillating cylinder engine mechanism is shown in a figure here with a different kind of links, which is used to reciprocating motion into a rotary motion. When the crank link 2 rotates, the piston attached to a piston rod link 1 reciprocating and the cylinder oscillates about a pin pivoted to the fixed link 3 at B. Next one is rotatory internal combustion or engine. In this mechanism, crank 2 is fixed, crank 3 is connecting rod, crank 4 is piston and crank 1 is a cylinder. From the figure, it can be observed that with the rotation of a link 3, the link 1 rotates about a point P point O, and the piston 4 is reciprocating on it. This also implies that if the piston is made up of reciprocating on the link 1 and the link 3 will rotate about A and the link 1 about O. In a rotatory engine, the crank 2 is fixed and the body 1, or the rotate where the reciprocating engine, the body 1 is fixed and the crank 2 is rotating about a point. This mechanism shows the rotator internal combustion engine. Nowadays it is not even be used. Okay. Next one is crank and slaughter lever quick return motion machine. This mechanism is mostly used in a shaper and a slotting machine, which is shown in a figure. In this mechanism, link 3 is fixed and the driver crank 2 rotates with a uniform angular speed about a fixed point A. A slider is attached at the end of a driving crank, which also reciprocating in slotted link 4 and thus cause oscillating the slaughter link about the point C. The link 5 transmits the motion from link C and CE to ramp which carries the 2. Since the driving crank rotates at a uniform angular speed, the ratio of cutting stroke to return stroke time will be given by. Since 5 is less than theta, the time required for a return stroke is less than the cutting stroke. Hence, this mechanism is called as a quick return mechanism. The time of a cutting stroke divided by time of a return stroke, angle theta divided by angle phi, equal to theta divided by 360 minus 5. In our next video, we are going to see what is Whitworth quick return mechanism. Thank you.